Hello and welcome to this session of the course Introduction to Autonomous Systems. You may recall that in the last lecture we introduced the idea of human level performance and a rational performance, and we also tried to give some interpretations to both these ideas. Let us now take them further and understand what exactly we mean by these two ideas and what is the current level of activity which is being carried out. So, let us begin this lecture. So, when we talk about concept of acting humanly, we are essentially talking about the fidelity of a human behavior, and this aspect we need to quantify. Now, one of the very elegant and very useful test which provides information in this regard was created by Alan Turing in 1950, which was later came to know as Turing test, and even today that seems to be a very much part of any AI system development process. This idea was actually crystallized by Alan Turing in 1950, who designed a test to provide satisfactory definition of machine intelligence. That was the idea, that he wanted to actually establish what exactly we mean by machine intelligence that we need to incorporate. So, this test was actually quite simple. He proposed that if you can create a computer to which, if some written questions are posed and that computer gives an answer, the human, if looks at those answers, is not able to decide whether those answers were given by another human being or a machine, then that particular computer would pass the Turing test. The implication was that if I pose a question to my friend, let us say, and he gives me an answer, and I pose the same question through a written material to a computer, which I do not know that it has been posed to a computer, and a printed sheet is given to me saying that this is the answer given by the other person, and if they appear similar, then I might get a conclusion that this was answered by some human being. That exactly was the test, that if essentially this meant that the computer now was behaving like a human, and this was in some sense coming close to the human level fidelity of behavior. And in order to come up with this test, there were many things which were required. First, it required the ability to process natural languages. It also required a skill to represent knowledge. It also needed the algorithms to automate a reasoning process. And then lastly, the ability of the machine to learn from the various inputs that were received, and those then became the starting ingredients of any artificial intelligence system, which would require capability to process natural language or natural language processing, knowledge representation, how do you represent a knowledge in a machine? Automated reasoning process, how do you reason out a particular conclusion and make a decision based on that, and to learn. I am sure many of you have now realized that this is exactly what the current set of chatbots are doing, notably the ChatGPT that all of us have been using for different kinds of questions that all of us have. And then of course, you have other ones like Gemini, or you have Copilot. So, if you look at all these initial AI tools that you now have, they are essentially doing these processes. For example, large language models are essentially a reflection of the natural language processing activity, and then of course, the knowledge representation in the form of a database, then the reasoning process, and it learns basically based on the questions that come and the answers are given, and if some of the answers are considered to be appropriate, then it is a learning for future. The next, let us look at the concept of thinking humanly. That was all acting humanly, that your behavior of a machine would almost give you the impression that there is some human sitting behind the machine and answering the question. But how does that machine think like a human? And this idea started with the premise that we can model human thinking mechanism, particularly if it is possible for us to get actually inside a human mind. And this has been the endeavor of many people over a number of years, to see if they can get inside a human mind, to see how it works, how it actually performs a thinking action. Because if you realize, as human beings, for us thinking is almost subconscious or automatic. We are doing it all the time, except perhaps when we are asleep, but maybe at that time our subconscious is still doing the thinking and we get kind of dreams. So, in essence, the thinking process is 24/7 for us humans, and we are not even aware that we are thinking. Many times it is so kind of subtle, but when you are trying to create a machine which is going to think like us, we need to have a better understanding of what goes on inside a human mind when we are actually thinking. In fact, people have found out that this thinking mechanism depends on 3 sub-mechanisms that humans are typically applying. That is introspection, that is one mechanism; observing a person in action, that is also when we are thinking; and observing a brain in action. I mean, if you do these 3 activities, like introspect, observe a person in action, and observe a brain in action, and I am sure many of you would have heard of this particular project which is being pursued, where there is an attempt to model or capture the activity of brain when a person is thinking, and for that reason a small chip has been installed in the brain of a volunteer. I am sure you have heard of this Neuralink, which is essentially trying to now generate large amount of information about what is happening inside the brain when a person is thinking of something. Now, the person possibly is not aware that something is there. So, when you think something, there are some certain signals which get generated, which is what this Neuralink is trying to capture, hopefully for better understanding of how the mind works when a person thinks. And then of course, there is a very big field of cognitive science which has evolved over a period of time that brings together computer models from AI and experimental techniques from psychology for testable theories of human mind. So, when we talk about cognitive science, which is a very critical field for creating artificial intelligence systems, is now trying to bring in the computer models from the artificial intelligence and experimental techniques from psychology to create theories for human mind as to what kind of action the human mind takes when it is thinking and whether that can be tested. When we talk about the concept of thinking rationally, there is a school of thought which says that it implies laws of thought approach. Now, this is where we talk about rationality as something which does not depend on an individual human being. What it means is that if there is a right thing to do in a context, then no matter who does it, that is the way it should be done. And they are based now on something called laws of thought. And this got codified as right thinking. In fact, we use this terminology in our many interactions with people. So, you say that okay, all right thinking people should come together. Now, what that right is, of course, is a very specific context, and it can be interpretative also, but the philosophy remains the same, that right thinking is doing the right thing, or what is called an irrefutable reasoning process. This was first attempted by Aristotle, a philosopher, who came up with this idea that if there is an irrefutable reasoning process, then our thinking is right. So, he started what is called a discipline of syllogism. He gave certain syllogisms and came up with argument structures that always yielded correct conclusions when given correct premises. So, this is the whole idea of a rational approach, that if you give the correct premises, you will always get the correct conclusions, which means if we have correct inputs, we will always give the correct outputs. You will immediately realize that in the context of humans, this perhaps is not as exact as we are now talking about, where a human given the same inputs could generate maybe slightly different outputs. Whereas, when we talk about a rational thinking human, you would say that if I give you a certain set of premises which are correct, you will give me a correct conclusion. So, an example was given just to show that this is how it works, that Socrates is a man, all men are mortal, so Socrates is mortal. So, you look at the first two which are premises, Socrates is a man, all men are mortal. So, the conclusion that Socrates is mortal is correct. Every time you give these two or similar kind of correct premises, you will generate a correct conclusions. Now, converse is also true, that is, in case you give a faulty premise, you are also going to get an incorrect conclusion. For example, suppose there are two persons who are supposed to go together and one of them leaves and then the other person complains that why did you leave without me, and the person says, I thought you were sleeping. He says, no, I was not sleeping. Now, you can clearly see that the premise that the other person was sleeping was incorrect, and because of that the conclusion that was drawn was incorrect. So, this is the implication of the syllogism, and this idea of laws of thought ultimately led to the initiation of the study of the discipline of logic. So, this is how the logic evolved. It was essentially from the laws of thought, and the logicians over a period of time actually have proposed that a program, a computer program for that matter, based on logic symbols. We will talk about some of these when we will start looking at the ideas of logic as part of this course. But at the moment it is sufficient to say that the logic symbols, if you use to create a program which has this laws of thought implemented and the premises and conclusions, the logicians say that they can solve any problem. Now, that is a very broad and very loaded statement, and if it is really true, then that solves all our problems of artificial intelligence modeling and implementation. But as we will kind of find out as we proceed forward, that there are certain things which we will need to also consider apart from the logic before we can come up with this idea that we can still create machines that can think rationally. Then came the idea of acting rationally. Acting rationally is usually visualized in the context of a generic concept of an agent, which is something that just acts. So, this is another development which was kind of initiated by the idea of acting rationally, that now that action has to be done by an agent. See, in the context of humans, we are two in one in some sense, that we think and then we act. But when we are talking about artificial intelligence, we need two things. One, the ability to think, that comes in the form of creating, let us say, an artificial brain, and acting rationally, which means a machine or an actor which then will carry out the action as decided by the brain. In our case, our body encompasses both. The brain also directly gives signals to the various parts of the body to execute functions. So, essentially it means that now we are putting these two ideas together and say that can we create an agent which will act rationally based on the rational thought that will be part of its brain power. So, if we look at all computer programs, they always do something. So, in that sense they are all agents. I mean, in fact, I can always talk about all computer programs as agents because they are doing something, but perhaps they are not thinking, because they are acting based on the statements that you have written, which means you as a human brain have thought out what action to be taken, coded them in the form of statements in the part of the program, and then when you execute the program, the action takes place. But now we are talking about that computer program which will operate autonomously, perceive its environment, persist, adapt, create, pursue goals, etc. All those things will have to be done. So, obviously, you will now need to provide that thinking skill so that it can adapt, it can create, it can persist, perceive its environment. So, all those things will be required to be part of that thinking rationally, which will have to come in as part of this concept of agent. So, if we were to now kind of define this rational agent in a nutshell, which is our basic building block for artificial intelligence systems, it is an entity that acts so as to achieve the best outcome or if there is an uncertainty, the best expected outcome, that can you improve or maximize the probability of an outcome. So, this is now what we are going to talk about as we go along, a rational agent, and then start looking at the various ideas of artificial intelligence through this same building block, what we call the rational agent. In fact, it has been realized that rational agent is an important tool of artificial intelligence, and it has also given rise to another kind of artificial intelligence, that is called agentic artificial intelligence or artificial general intelligence, as against generative artificial intelligence. So, this idea of a rational agent is central to the whole philosophy of creating AI systems. And when we say that we are going to act rationally, indirectly we are saying that we are also going to think rationally. The implication is that when you do the rational thinking, you are going to come up with conclusions which are correct, and that if they are acted upon, the outcomes will be correct or what you desire. And then now we tie this rational agent to our Turing test, which was essentially for capturing a human behavior. So, we say that all skills needed for Turing test to come up to the human fidelity level, they also allow an agent to act rationally, because knowledge representation and reasoning help it to reach good decisions. You remember that we just now talked about those 4 ideas, which included knowledge representation, reasoning process as part of the Turing test. If we put all that as part of our rational agent, then we are sure that when this rational agent acts, it will reach good decisions. Lastly, the rational agent approach, even though we may get an impression that it is primarily driven by laws of thought, it is also mathematical, so that it can enable a generic design process for the agent, which means now it can bring in other disciplines, including optimization, other engineering aspects can come into it, and together now they can create something which is far beyond what laws of thought kind of indicate. Of course, there are also limitations of rational agent approach. One of the major drawbacks that the rational agent approach has is that in complicated environment, it may not be possible for the agent to always do the right thing, particularly when things are very complex, not correctly captured, there are uncertainties, unknown things. It is possible that the agent may not do the right thing. So, that is going to be one of the stumbling blocks that we will have to look at and see how we can get around it. Of course, many times the things may not be complicated, but they may just be so vast that the computational requirements may be just too high for the process to be of any practical value. Of course, both these limitations, it is still a good starting point for the analysis and beginning of the study of artificial intelligence, that we can start with the assumption of a rational agent, and at some point we may even consider the realism as part of our design and say a limited rationality is acceptable, which sometimes is called acting appropriately, which means it is not completely rational, but in a given situation it is acting appropriately. So, if the situation changes, the action could be different. So, to conclude, AI has provided the concept of an intelligent rational agent, and we will find as we go along that this is the basic building block for any AI based system. So, with that we come to the end of the present lecture. In the next lecture, we will start looking at some of the details of how the AI has evolved and what is its current status and where it is leading us into the future. So, bye for now. Hope to see you in the next lecture, and thank you.